Thanks to everybody who asked questions. This is video 3 of 4. Many of the answers are in videos that I've done in the past. You can find past videos by going to eagerspace.net and searching around. On to the questions. Jared Isaacman is confirmed as NASA administrator and gives you a call asking for advice on NASA's direction over the next 4 years. What do you tell him? I responded to a post of his a while back on Twix, and I had one bit of advice. The advice was to fix NASA's transparency problem. NASA's policy about the release of information starts with 2 requirements. NASA, a scientific and technical agency, is committed to a culture of openness with the media and public that values the free exchange of ideas, data, and information as part of scientific and technical inquiry. Consistent with NASA's statutory responsibility, NASA will provide for the widest practicable and appropriate dissemination of information concerning its activities and the results thereof. NASA is not adhering to either of these. Let's take one example. NASA conspired to hide the unexpected Orion heat shield erosion during Artemis 1 from the public, and it only came out 16 months later in an IAG report. I use the word conspired deliberately. I have a copy of the post-flight briefing deck for Artemis 1 that I got through a Freedom of Information Act request, which is very frank about issues, but contains no details about Orion, and there is no video record of the meeting available. This past December, we were notified that the expert team assigned to investigate the issue had determined the root cause, but the investigation report was not released. I have an open FOIA request for that report. This is an egregious example, but in general, NASA has stopped releasing contracts and many other details that previously would have been released. NASA used to regularly release complete mission reports for shuttle flights. We've seen nothing like that from Artemis 1. What are the implications of commercial space stations failing? Could that give justification for continuing Gateway or expanding it? I did a video on Gateway, and the short story is I don't think it makes any sense. The only way to get astronauts there is on Orion, and that's at least a $2 billion trip. Is Crew Dragon delivering crew to Gateway possible? If so, what are the chances of that happening? I talked about a few scenarios in the commercial moon video. Falcon Heavy probably has enough oomph to get Dragon to Gateway. The problem is that Crew Dragon probably doesn't have the life support for 4 astronauts for that trip, and the heat shield is rated for low Earth orbit re-entry, not for the much higher speeds of re-entry from the moon. I don't think Gateway makes any sense, so I'm hoping that the Gateway part won't happen. Can you do a video on startup Stoke Space? They're working on reusable second-stage rockets. Sure. What's the most obscure topic you ever stumbled upon in your research for videos? I'm really not sure. I've read a lot of weird papers. Spend some time on the NASA Technical Reports server, and you'll find them. Here's a good read that is somewhat obscure. Granted that China has its own secrecy, are you ever going to do a video dedicated to their launch vehicles and aspiring launch vehicles? Very unlikely. I don't have a lot of passion there, I don't have good information sources, and it's hard to figure out what is real and what isn't real. Maybe if they start flying reusable prototypes, maybe I'll talk about that.
Is your favorite color blue? No.
Do you think the space shuttle was not worth making? Do you think the 30 years between shuttle and the more economical reusability of SpaceX was a waste of time? Could you show off any alternative concepts for shuttle that would have been safer or easier to reuse? Here's a video for you. Shuttle did what it was supposed to. It kept NASA in the rocket and astronaut business. With respect to alternatives, I talk about that in this video. The short answer is that NASA got the absolute minimal shuttle because that is what Congress and President Nixon were willing to pay for. How would you repurpose the ISS for the Moon or Mars missions? I don't see any direct way to do this. I guess you could use it as a stopping off point, but the ISS is at 51 degrees of inclination so that the Russians could easily reach it, and launching to 51 degrees imposes a significant performance penalty if your launch site is in Texas or Florida. In other words, it's not really on the way to either destination. Wealthy tech bros taking Instagram models to a private space hotel for a weekend might be the start of serious space tourism. What are the minimum requirements for such a hotel? Food, cleaning, spacewalks, toilets, etc. This sounds like a good homework assignment. I'm sure there are existing design guidelines for terrestrial hotels that you can apply to space. Thoughts on space solar? I think this video covers it. The short answer is that some of the increase in efficiency you get from being in space is lost during power transmission, and the launch costs kill you. Plus, you're fighting thousands of companies dedicated to making terrestrial solar cheaper. How much delta V can Starship get with 1 or 2 expendable kick stages? Is a repeat of New Horizons possible without gravity assist? Or direct to Uranus-Neptune orbit, not a flyby? My guess is that you can find the delta V to do those sort of missions, and calculating what you get from a kick stage is also straightforward. The proof is left as an exercise for the reader. Try looking at the Impulse aerospace stages to start. Why has Methalox so quickly displaced Hydrolox and especially Kerolox in the last 2 decades? Was there a specific breakthrough, or is everyone just following Raptor's direction? I think it's pretty simple. Methalox is cheap. Methane is dense enough that the tanks are reasonable size, which isn't true for hydrogen. There's no coking like RP1, which helps a lot if you're going to do reuse. It's way less hassle than dealing with hydrogen. What is your expertise on best type of rocket engine and fuel type for best case use? Example for small, medium, large size class rockets. Reuse case, safest architecture, etc. There are hundreds of different factors that determine what is the best choice. I talk about the process that companies use in this video. How realistic or viable are alternative and futuristic ways to get into orbit? For example, spin launch, air-breathing single stage to orbit, launch from airplane, launch by gun, space elevator. I've done multiple videos on these concepts. None of them really make any sense. During a discussion about whether to colonize the Moon or Mars first, I had an interesting thought. If we use Mars' atmosphere for orbital ascent and landing, its delta V requirements are surprisingly similar to, or even lower than, those of the Moon. So my question is simple. Which is better for colonization, the Moon or Mars? If you can aerobrake on Mars descent, the delta V to get material to Mars is considerably less than getting the same material to the surface of the Moon. It's harder to get back from Mars, but in any colonization mission, the vast majority of the material will flow from the Earth to the colony, not the other way around. I think there are numbers in my Planning Your Solar System road trip video. When will in situ resource utilization propellant manufacturing on the Moon or Mars gain relevance? When you have enough local demand that it makes economic sense to invest in ISRU in general. ISRU will require a ton of investment, and therefore you need a big, stable market and a lot of demand for it to make sense. Otherwise, it will be a great way to lose $1 billion. I've been wondering about the impact of orbital inclination on payload capacity, especially on high parasitic mass vehicles like Starship or Stoke. A few general rules. Getting to a higher inclination is relatively cheap, assuming you can launch far enough to the north or the south. Getting to a lower inclination is expensive, even if you're going to a high orbit like GEO. Find yourself a good Hohmann transfer calculator to tell you the difference in delta V costs between orbits, and build yourself a model using the rocket equation, and play around. Your answer will be wrong, but it might be close enough. KSP might also work for this. Also note that the market is in transition. A decade ago, a lot of money was launching to geosynchronous transfer orbit. But LEO and lunar have been taking over, and the cost of getting to low inclination doesn't matter for those launches. Do you think the US will return humans to the moon before China lands humans on the moon? No. The Chinese have a well-defined incremental plan, and getting to the moon is a matter of national pride. Artemis is a weird patched-together architecture that is likely to keep slipping, and getting back to the moon is not a matter of national pride for the US. What's your favorite projects that did or didn't come out of the Soviet space program? It has to be Energia. Buran was a pretty stupid idea. It's not clear to me why Russia ever thought that a space shuttle was a great idea. But NPO Energia built an absolute killer super heavy launch vehicle with a bit less payload than the Saturn V. They flew it twice, once with the Polius military payload and once with the Buran shuttle. And that's it. And yes, there was a reusable architecture that they considered. Why isn't SpaceX using scale models of Starship instead of full-scale, cost versions of the vehicle? Scale models were often used in wind tunnel testing, but that has largely been replaced with computational fluid dynamics. For anything else, it's difficult to test with scale models. Mass varies with the cube of size, surfaces vary with the square of the size. That messes up the ratios between lift and drag. There's also the engine problem. If you want to test a scale model of Super Heavy and Starship, what engines are you going to use? What are the future sources of revenue for commercial spaceflight that you think are most exciting and/or most likely to play a big role? Are asteroid mining, space tourism, or orbital industry plausible in the near or medium term? Let's look at them in order. I've whined about asteroid mining not being practical in the past. I think Astroforge has a good startup plan to explore if there is something possible in that area, but they're a long way from being commercial at this point. Space tourism is currently blocked by transportation costs. It's also pretty uncomfortable in orbit, and that's going to be a fundamental problem. I do think there may be a cruise ship approach rather than a hotel approach, but that will have to wait for an upcoming video. NASA has been searching for the killer orbital industry app for decades, and hasn't really come up with anything under the current cost structure. That might change if Starship drops the price to orbit significantly, but I'm still a bit skeptical. Is Dream Chaser a viable option for sending crews to the ISS? Currently, the only contract they have with NASA is for the cargo version. A crewed version could come in the future, but it's not clear what happens after ISS. Could you do an in-depth review about ESA and their new Ariane 6? I haven't done anything on Ariane 6 because it's really not much different from Ariane 5. Out of New Glenn, Neutron, Falcon 9, and other companies, is a reusable second stage possible, and if so, who do you think will achieve reusability first, excluding Starship and Stoke? My answer is none of them. New Glenn is big enough that it could conceivably work, but the word I've heard is that their Project Jarvis got cancelled a few years back. Neutron is probably too small to do this sort of thing, and there's no way SpaceX will try it on Falcon 9. Can you analyze the realism in Musk's goals to get to Mars in 2 years? How do you expect such a mission will turn out? It depends totally on how fast Starship progresses, and I have no way to figure that out. I can see scenarios where they can easily send a couple of starships, and scenarios where they have no way they can send starships. Why does ISRU focus on making traditional bipropellants instead of hypergolics? Liquid oxygen is easy from gas, as is hydrogen. Methane is a bit harder, but the synthesis is relatively cheap. Hypergols are much harder to synthesize, require very special storage, and are toxic as hell if there are any leaks. And that's all for this set of questions. If you enjoyed this video, listen to this. The Chinese have a well-defined incremental plan, and getting to the moon is a matter of national pride. Artemis is a weird patched-together